Hello there, this is Ms. Nakayama. This is 6.7, Modeling with Exponential and Logarithmic Functions. This is the last section for our chapter test on exponents and logarithms. So the first part, I'm going to talk about regression with exponents and logs. You know how to use this in Delta Math, but I just want to quickly go over how to do it with exponents and logs. So our first problem, the accompanying table shows the number of bacteria present in a certain culture over a 5-hour period, where X is time in hours and Y is the number of bacteria. Right? And so the key when you do these problems, y'all, is paying attention to this right here. I cannot tell you how many people miss these simple problems because they don't read. It says write an exponential equation, regression equation for this set of data, rounding all answers to the nearest hundredth. So our equation, we're going to have to round to the nearest hundredth. So let's go figure out if I know where it is. Right here. So this is that same problem I just read to you. Okay, exponential regression. You know what to do. You copy the values. You open the statistics calculator. You paste the values. Then you're going to go to the calc menu. And so what's different is you've got to choose the right equation. All right, so what are we doing? We are doing exponential reg. So you don't need the diagnostics on, so calculate it. And so it told us to round to the nearest hundredth. So we're going to have 744.38 and 1.09. So if I go back to that, hopefully I have my equation here to make life easy for us. All right. Using this equation, determine the number of bacteria after 16 hours rounded to the nearest whole number. So what does that mean you're going to do here? I think you know that means you're just going to plug in 16 for X. So on your calculator, and you should do this to make sure you know how to do it, 744.38, because it told you to use that equation, 1.09 to the 16. And when you do that, and you will get 2,955 rounded to the nearest whole number. So that's your answer. All right, look at the second one, which I have here for us. All right, company table shows the value of a car that was purchased for $18,200. X is in years. Y is the value of the car in dollars. Write the exponential regression. So again, we are doing exponential regression. This time we're rounding to the nearest thousandth to get our table. So let's go back to, I don't need that calc stats anymore. I'm going to go to the next equation. I'm just trying to make it as short as possible because I think y'all know what to do. All right. We talked about the car worth $18,000. Copy. Open the stats calculator. Sorry, computer's not that fast. Paste. Go up to calc. And our problem said exponential regression. You might want to double check that when you're on your test or quiz. Exponential greg. And then I'm going to round it, and it told me to round to the nearest thousandth. So this one gets taken out. That's the 0. Look to there's 4. So 620 or 62, and then 845 are going to be our numbers. So let me go back to our problem, and our equation is going to look like that. Now, using this equation, determine how long it will be. So if you remember up here, it says X is the number of years, Y is the value. And if they're asking me how long, that means I'm looking for X. So in this particular case, I'm going to have to plug in for Y. What is the amount? 3,800. So I got 3,800 equals that 17859.62 to the 0.845x. Okay? We're looking for x because we're looking for how long. Okay? How many years. So I'm going to divide by that 17859, and I'm going to get a decimal. It tells me to carry it out to the nearest tenth of a year. So I get a little paranoid. So I'm going to carry it out. 0.2128 equals 0.845 to the x. How do I solve it from here? I got a variable in the exponent. I got to take the log of both sides. So I'm going to take ln of both sides. And remember, I get to move this x down front when I do that. So I have ln of 0.02128 equals x times ln of 0.845. So I'm going to divide both sides by ln. And y'all, this is not hard. And I promise you, when people make mistakes, it's only because they're skipping steps. So if you just follow the steps, I don't think you'll have any trouble with it. Okay? Punch that in calculator. Make sure that you can get the right answer, which when you put that in, you're going to get 9.188. So to the nearest tenth of a year is going to be 9.2 years. So that's the answer. All right, number 3, of the students scoring 50s, let me go back to this. We'll just close that calculator and go to the next one. Of the students scoring in the 50s on a practice test, the following study times resulted in certain test scores. In the accompanying table, X represents the study time in hours, and Y represents the final test score. Now I know why I was using this one, because then I can say and highlight the important information. Always good to know X represents study time in hours. Y is your test score. Logarithmic regression to the nearest 10,000th. So now, when I go back to this, I'm going to copy, open, paste, calc menu. But this time we're not exponential, we're logarithmic. And notice that it is ln for the natural log, so that's what we're going to be using. And look at the equation, y'all. Y equals A plus B ln x. So you've got to be careful about that. You've got it right there. A, what did it tell us to round to the nearest 10,000th? So that means we're going 1787 and 5407. So we will go back to our problem and put that equation down there. 1.61.1787 plus 8.5047 ln x. Using this equation, find the estimated test score. So we're looking for that for a student who studied 23 hours. 23 hours, x represents hours, so that means I get to plug that in for x. So when I do, that's going to look like 61.1787 plus 8.5047. Nope, not yet. ln of 23. So when you plug that in, you're going to get 87.845. Rounded to the nearest integer would be 88. So the test score is 88. Okay? So quick review on exponents and logs. Now let's look at our applications of exponents and logs. So what we have, these are dealing with mainly the expression for exponential growth and decay. Y equals A times the quantity of 1 plus R to the T. Now, remember, it's either plus or minus, depending if we have growth or decay. So look at this first one. Given the following exponential function, identify whether the chain represents growth or decay and determine the percentage rate of increase or decrease. So when you look at 1.063, y'all know that that is clearly larger than 1, and since it's larger than 1, it has to be growth. So how do I find out what that growth is? All right, if it's bigger than 1, it's growth. So I just need to subtract 1 from that. Pause 1 second, please. Back in gym. So I'm going to subtract 1 from my 1.063 and find out that it's 0.063. And so to find that percentage of the percentage rate of increase or decrease, you have to change this decimal to a percent. So my answer is going to be 6.3%. Okay. B says, given the following exponential function, identify Identify whether the change represents growth or decay and determine the percentage rate of increase. So my equation, 720 times 0.23 to the x. Well, my b is the base in parentheses, and that number is clearly less than 1. So I hope you know that means it's decay. And how did they get that number? This 0.23 is the result of 1 minus the rate. So I can switch those two and say, okay, well, what's 1 minus 2.23? That's 0.77. So that's my rate, 77%. And of course it is a decrease because we said decay. All right, look at C. Mason is going to invest in an account paying an interest rate of 5.3% compounded quarterly. How much would Mason need to invest to the nearest $100 for the value of the account to reach, why are you doing that? To reach $205,000 in 14 years. So, compounded quarterly, this is a compound interest formula. You need to know that formula. A equals P times the quantity of 1 plus R over N raised to the NT. So I'm going to go plug in for my information A. I want it to get to 205,000. P is what I start with. Well, that's what they're asking me. How much money should he invest? 1 is always part of it. R is my 0.053. N is how many times it is compounded in a year. So if it says quarterly, then N is 4. And up here, I'm going to get 4 times T, which is going to be 14 years. So this right here, y'all, is just a decimal. So to solve it, there's nothing fancy about this. You just plug this into your calculator, and 205,000 divided by that number is going to give you the answer, which in this case is 98089. It said round to the nearest $100. Where's my hundreds place? This is my hundreds place. So that's going to be $98,100. So a little bit of making sure you know how your place value and know how to round. All right, 2 more, then we're done. Lydia invested $83,000 in an account paying an interest rate of 6.7% compounded monthly. Okay, so I know you know that N equals 12. Assuming no deposits or withdrawals are made, how long would it take to the nearest year for the value of the account to reach 210,100? So same formula that we just dealt with. And this time we're trying to get to 210,100. My P, what am I looking for? Assuming how long would it take? So this time I'm solving for T. I know what P is. I started with 83,000. My interest rate is 0.067. My N is 12. And so 12 is up here, and then T, because that's what I'm looking for. I don't know if y'all are aware. I mean, you can type in your calculator, so it's not really that big a deal. But when you have this problem, if you have the same number of zeros on both sides, you can cross them out. Just makes your calculations a little bit easier. So I really didn't have to pick up a calculator for my next step because I'm going to divide, y'all. If my variable's in the exponent, I've got to get this thing by itself before I can think about how to solve it. So I got to get rid of the 830. So that's going to give me 2101 over 830 equals this number on the inside of the parentheses, which becomes 1.00558 raised to the 12t. Now, we're solving for t. I got to get that variable out of the exponent. So how do I do that? We solve exponential equations, variables in the exponent. I either write them as a common base, I can't do that, or I have to use logs. And so I'm going to take the log of both sides. And when I get to do that, this gets moved down in front. And it looks like I might have skipped a little step here, but it gets moved down in front. And then, y'all always do this to me, so I'll do it to you. Skip. So t is equal to what's on the left is on the top, ln 2101 over 830. And then I'm going to have the ln of the 12 times ln. So if you're getting confused, y'all, this right here when you move it in front, looks like this. 12t ln of 1.00558. So you're dividing both sides. It's all multiplication. So that's why you're dividing by 12 ln of 1.00558. Put that in your calculator and make sure you can do that accurately. You're going to get a number of t equal to 13.9. To the nearest year is going to be 14 years. Okay? All right, last problem. It's a doozy. Mackenzie is going to invest $3,900 and leave it in account for 16 years. Assuming the interest is compounded daily. Stop. What is the interest rate? So this time we're looking for the interest rate to the nearest 100% that would be required in order for Mackenzie to end up with $5,800. So we're still using that formula. All right, and I want to end up with, she wants to end up with $5,800. She started with $3,900. This time we're looking for the interest rate. So that means I don't know what R is. N is daily. We've discussed that. Daily is 365. So we have 365 and T is 16 years. So that, remember I just talked about that. I've got a 0 and a 0 on both sides and another 0, 0 on both sides. So I'm going to get 58 over 39 is equal to, can't do anything with what's in the parentheses. So I've got 1 plus R over 365, and 365 times 16 is 5840. So my variable is not in the exponent. I don't need to take logs. I don't need to do logs, y'all. My variable is inside this parentheses. So I got to get rid of this 5840, which means I raise it to 1 over that, or take that root of both sides. So that's on the left, we have a decimal. And y'all, you can't round, especially when it looks something like that. You just got to write the whole thing out. Equals 1 plus R over 365. Okay. Subtract 1 from both sides, and it looks like that. And now you multiply it by 365 to solve it, and look at your rate. So if you had rounded this decimal to just 1, you're going to mess up the whole problem. Okay? So, more importantly, give that to the nearest 100th%, which means move that over 2 places. So I've got R is equal to 2.48%. And that's all we have for applications of exponents and logarithms. If you have any questions, please don't hesitate to come see me or email me. Thank you so much for watching, and y'all have a great day.